Okay. Now I gave you the exercise to do last time, and I hope you did it, isn't it? Did you manage to do that? Anyone? Did you manage to do the
Yes.
exercise? Oh, okay, that's fine. And didn't get any challenges? Let's hope so. Now, if you recall, last time I was supposed to just highlight something. Then we realized that the window that I was using was not allowing me to do that. So today I think we can start from there. Try to show you something that can assist you, especially when you are fitting a regression line or a trend line. Those are the things that you have to know. So let me just go there. Go to the share of screen. Okay. Okay. Can you be able to see my window?
Yes, sir.
Okay, now we can start. Let's start from there. Then from there, we are going to start with our chapter 2. It's about fitting the regression line when we are applying the zero-sum method. Using zero-sum method to fit the regression line. Remember, I told you that regression line is defined by y equal to beta 0 plus beta 1 x, where beta 0 is given by y bar minus beta 1 x bar. Not x bar, yes. If you still recall, which is equivalent to summation of y over n minus beta 1 summation of x over n. But in this case, because now we are dealing with the zero sum, method, so this part here equal to 0 because it's a zero sum. So the sum of x is equal to 0. So if sum of x is equal to 0, the whole of this will be 0. Okay, then you are left with, therefore you are left with beta 0 is equal to y bar. In other words, when you want to fit a regression line using zero sum method to calculate the y-intercept, which is beta 0, you just use this formula. So that formula reduces to beta 0 equal to y bar. So you don't have to worry about all those other things. Just go to beta 0, then you use y bar. Is then that you can find your y-intercept. Only if you are fitting a regression line using zero-sum method. Are we together? So the same applies to beta 1. If you want to calculate beta 1. You know that beta 1 is equal to n summation of x1 minus summation of xy, summation of x, summation of y, sorry, all divided by n summation of x squared minus summation of x all squared. So this is the formula of calculating the slope of a gradient. So, but now, because we are dealing with the zero sum, we know that the summation of x is equal to 0. So therefore, this part is 0. Okay, even here is 0. So all in all, the whole of this part will be 0. And the whole of this part will be 0. Therefore, this one cancels this one. Then you are left with what? With summation of xy divided by summation of x squared. So therefore, instead of using that complicated formula, we end up using beta 1 equal to summation of xy divided by summation of x squared. I think it's clear, isn't it? This is something that I wanted to highlight last time. So that's why I said no. Let's start from here before we proceed to chapter 2. So now this concludes chapter 1, which is an introduction. So now we're going to chapter 2, which is another real stuff now. Something that maybe you don't know, is the first time to come across with, because in chapter 1, many things you know them. It was the matter of just reminding you. So this time around, we are going to start with something new. So you have to be careful and listen very, very careful on that. So let me just go to page number 2. Or maybe, because these ones, you have them, so I can just erase them, then I start afresh. That's chapter 2. Agree? Can I erase
Yes.
everything? Okay, thank you very much.
Yes, sir.
Let me just,
Yes. Yes, sir.
okay, thanks. Let me just erase this. So that we can start with chapter number 2.
Sir,
Yes, ask.
are we going to use the same formulas when we are using the sequential numbering method?
The formula that I have introduced. No, for sequential numbering method, isn't it the main idea is to code variable x? After coding variable x, is then that you can use all those formulas that I have highlighted there to find beta 0, beta 1. But the one that I've introduced just now is for zero sum. Did you get it? Did you get it?
Yes, sir.
Okay, thanks. Okay, let's quickly go to chapter 2. For those who are having the notes book or lecture notes, it's page 19, 2.3. We are going to start with the stationary time series, sorry. Okay, let me say this now is chapter 2. And we are starting with the, you know that chapter 2 covers the model building, where 2.1 is the introduction, 2.2 box janking techniques. So forget about that one. We're going to do them later. So we quickly go to 2.3, which is stationary time series on page 19. stationary time series. What is a stationary time series? Remember, the stationary that we're talking about is not for the pencil, pen, and the books and all those things, and eraser. You have to differentiate this. Stationary for the books is having E here. Let me show you. I think it's having E here. Okay. But this one is A. So you have to differentiate that. So here's A. So what is a stationary time series? Now, a process or a time series process xt is said to be stationary if the mean, variance, and covariance are all sorry, independent of t together. A process or stationary time series is a process xt where the mean, the variance, and the covariance are all independent of t. In other words, what do we mean? You're having a process. We just want to check if that process is stationary. To do that, you have to calculate the mean, you calculate the variance, you calculate the covariance. If all of them don't depend on t, so the process xt is stationary. Are we together? You have a process, you calculate the mean, you calculate the variance, calculate the covariance. All of them must be independent of t. If when you calculate the mean, you find that it depends on t, so the whole process is not stationary. But if you calculate the mean, you find that it doesn't depend on t. You go on and calculate the variance. You find that the variance depends on t, then you conclude that the process is not stationary. Then, if you calculate the mean, you find that it doesn't depend on t, variance doesn't depend on t. You have to go on and calculate the covariance. And then when you find that the covariance is depending on t, therefore the whole process is not stationary. So the process xt to be stationary, the mean, the variance, and the covariance, all of them must be independent of t. They must not depend on t for the process to be stationary. I think it's clear, that one. So now, if the process is not stationary, we have to apply one of the transformation method. If the process is not stationary, we have to apply one of the transformation method. So the transformation method are as follows. Number one, we have differencing. That's number one. Number two, we have action transformation. Sign transformation. The third one is called power transformation. The next one is square root. Transformation. And the last one is called log transformation. Those are the methods that you can use to make your process or your data to be stationary. It's either use the differencing or upside transformation or power transformation, square root transformation, or log transformations. So now in this module, we are going to concentrate more on the differencing. We're going to concentrate more on differencing, this one. This is the one that we are going to concentrate more on. Okay. Let me just go to the next page. So those things you can find them on page 20 of your lecture notes. Okay. The next page. The question is, why do we transform the data? Why do we transform the data? In other words, reasons for data transformation. Number one, we just want to stabilize the variance. To stabilize the variance. Sorry. Stabilize the variance, that's number one. Because sometimes you can find that they are increasing, so we just want to stabilize them. Number two, to make the data to be normally distributed. That's number two. Number three is to make seasonal effects additive. So you can find the whole information on page 20. So those are the three main reasons for data transformation. So now let's quickly go to differencing. What is differencing? What is differencing? Remember, we difference the data if it's not stationary. So, by the way, what is differencing? So, differencing is a trend removal operation by using a special kind of transformation, or let's say kind of linear, special kind of linear filter with weight CK. So you will understand later when we talk about linear filter, what is a linear filter and what is a weight. You will understand later. Don't worry about that. But anyway, differencing is a trend removal operation by using a special kind of linear filter with a weight CK. So how do we denote differencing? Let's start with the first differencing. First differencing, sorry. So the first differencing is denoted by this change in xt. That is first differencing. It's first differencing, which is equal to xt minus 1. So the first differencing is denoted by change in xt, which is equal to xt minus 1. We are saying that it's a first differencing because our d is equal to 1 there. Okay. If you check change in xt, it's having 1 at the top there. It's just because it didn't want to write it, but there is a 1 up there. So that is why we're saying it's a first differencing. That one represents that d, which is differencing. So it difference only once. So, but we're saying that first differencing, which is changing xt, is equal to xt minus 1. But xt minus 1 is equal to bxt. Yes, has to be noted that xt minus 1 equal to that one. So from that equation there, or formula up there, we can substitute xt minus 1 by bxt, and you get what? Changing xt equal to, let me just write in full first, xt minus 1. So then xt will be equal to, then you substitute your xt minus 1 by what? Sorry, supposed to be minus, then you substitute your xt minus 1 by b xt. Are we together? So this now is equivalent to 1 minus b xt. Okay. So therefore, we can confidently say that xt minus 1, which is the first differencing, this part, the whole of this part, can start from here and get this one. So in other words, xt minus is equal to, okay, come again.
Where does that B come from?
B. Okay, B is a what we call backshift operation. I'm going to introduce it now after this, after explaining this, what I'm doing here. So I'm saying that xt minus 1 produces 1 minus b xt. So in other words, xt minus 1 equal to 1 minus b xt. So then from minus 1, from 1 minus b xt, this part, you can go back here. Okay. So by so doing, we are applying what we call it backshift operator. Oh, sorry. Backshift operator. It's where B is coming from. So that B represents the backshift operator. Backshift operator in such a way that from left you can go to right. When you are on the right, you can go back to the left. So that is why we call it a backshift operator. So that B represents backshift operator. What does that mean? If you have been given a process which is changing xt, which is equal to xt minus 1, and the question says write that process in backshift operator. So your backshift operator will be 1 minus b xt. But if you have been given the backshift operator, this part here, and the question says write it in the form of xt minus 1. So you have to go back and produce this part. So from backshift operator, you can go to the normal. From normal, you can go to the backshift operator. So that is why we're saying it's a backshift operation. Okay. Then you know that
Sir,
come
can you hear me?
yes, yes.
Are you saying that the change in xt is equals to the bracket of 1 minus b xt?
Yes, that's true.
Okay.
Okay. So we say that xt minus 1 equal to b xt, if you still recall. So similarly, xt minus 2 will be equal to b xt minus 1. Okay, but you have xt minus 1. So instead of xt minus 1, you can substitute it by bxt. So this is equivalent to b open brackets bxt, which is equal to what? B squared xt. So xt minus 2 is equal to b squared xt. The same applies to this one. Xt minus 3 is equal to bxt minus 2. Can you follow the scenario? Which is equal to, but xt minus 2 is equal to b squared xt. So we take this b here, this one, take that b, open brackets, multiply by xt minus 2. Xt minus 2 is what? B squared xt. When you open the brackets, you are going to get what? B cubed xt. So in other words, xt minus 3 is equal to b cubed x3. So if you can just go like that, we end up generalizing. Xt minus j will be equal to b x what? You can tell me. Xt minus 3 is equal to bxt minus 2. What about xt minus j? Will be equal to bxt? Come on. It's equal
J
to
minus
xt.
1.
Come again?
J minus
G
1.
G plus 1.
Not j plus 1.
J minus
Xt.
I think t minus in bracket j minus 1.
It's not
Sir, it's b to the power j xt.
to the power.
I
It's
think
not this one.
it's I
b
think
to the
it's
power
t.
j xt.
It's
I
supposed to
think
be this one. Remember, j is a one thing. Okay, let's
yeah.
take it as a one thing. J is a one thing. So it's xt minus j minus 1, which is equal to b, open brackets, b to the power, anyone?
J minus 1.
Yes, j minus 1. Very good. Xt. Then the last part,
b to the power j xt.
Yeah, b to the power j xt. So this is a scenario that you have to follow. So this is how we write the backshift operator. Okay, now
Sir, is the j minus 1 inside the bracket?
yeah, it's a one thing. So that's why we put it there. So,
All right,
so it's
sir.
a one
Thank
thing.
you.
It's like j minus 1 is a b or something.
All right.
Yeah.
Thank you.
Okay. So now, let's say, okay, let me just go to the next page. Let's say you have got change in xt squared. This one is the second differencing. Remember, first differencing is change in xt. So second differencing is change in squared xt. So now this can also be written as what? Change in xt, isn't it? And this can also be written as what? 1 minus b. 1 minus b xt. So let me take you back so that you can understand this. Remember, change in xt, this part here is equal to this part here. So therefore, changing is the same as 1 minus b. So that is why here we are having changing, instead of writing changing, just write 1 minus b, changing 1 minus b. So changing xt squared is the same as 1 minus b, 1 minus b x squared. Okay, think you got it. So this is equal to, so here 1 minus b, 1 minus b, you can just open the brackets, isn't it? So the answer will be 1 minus 2b plus b squared, if you still recall, xt, isn't it? So now this expression is in backshift operator. So we just want to take it back to the original. In other words, to xt, xt minus 1, xt minus 2, and so on. So how do we write this one? Taking it back to the normal position. Because now here is in backshift operator. It's equal to, okay, it's going to be equal to xt
Multiply by xt inside the bracket, and therefore converting the backshift operators into the subscript.
So we are going to have xt minus 2, xt minus 1 plus xt minus 2. So this is how we write the backshift operator. So that b now is xt minus 1, b squared is xt minus 2. So that's it. So therefore changing xt squared is equal to this one. So for those who are having the lecture notes, you can find it on page 21.
Sir,
Yes.
can you explain again step 2? Can you?
Step number 2. Okay. Let me start from step number 1 so that it can be connected. I said here, change in xt squared. This is the second differencing. Let me call it second differencing. Second differencing in the sense that here our d is equal to 2. Okay, the power there is d, which is equal to 2. So changing xt is equal to squared, changing times changing. So because changing and changing, when you multiply them together, is squared. So, but when you check this one from the previous page, when you check this change in xt, it's equal to 1 minus b xt. So in other words, changing is the same as 1 minus b. So where there is changing there, you put 1 minus b. Put 1 minus b, then you introduce xt. But this one is within the brackets. Now you just want to open the brackets. You know this. This 1 multiplied by 1 is 1. 1 multiplied by minus b. 1 minus multiplied by minus b. Then you add them together. It's going to be 2 minus 2b. Then you multiply minus b and minus b. Then you get b squared within the brackets. Then xt. So now this part, this one, it's in a backshift operator. So we just want to write it in the normal way. So this xt is like it's multiplying everything which is within the brackets. So xt times 1 is xt, then minus. So xt times 2b, it produces 2xt minus 1. And xt times b squared, it produces xt minus 2. So at the end of the day, the second difference is equal to xt minus 2, xt minus 1 plus xt minus 2. So now, if I want you to derive this one for me, derive the expression or the expressions of the following processes. Okay. Number 1, xt. So this one is the third difference. Number 2, this one is the fourth difference. Remember, when we difference, normally you have to, isn't that we are differentiating the process which is not stationary? So you have to do it for the first time. If it's not stationary, you go for the second time. If it's not stationary, you go for the third times. But remember, you must be aware of the over differentiating. Normally we differentiate it once or twice. If you go for the third time, so you have to think about the over differentiating. So, but here, because now it's just a matter of just practicing, I just want you to go and find out the expression of changing cube xt, which is the third differencing, and changing fourth xt, which is the fourth differencing. So you're going to do this on your own time. So let me just continue with the linear filter. If you remember, I said differencing is a trend removal operation by using a special kind of linear filter with a weight ck. So we just want to understand what is a linear filter. What is a linear filter? Can I go to the next page?
Yes.
Okay. Let's go to the linear filter. Linear filter is a linear transformation. Linear transformation or any operator which converts one time series let's say called xt, to another time series, which is called yt. Okay. So a linear filter is a linear transformation or any operator which converts one time series called xt to another time series called yt. Where in this case, where the time series xt is called the input, okay, and yt is called the output. Okay. So can you just illustrate this using a diagram? In other words, you have got a time series here called xt, okay? You put it inside a filter. This is a filter. Then it produces another time series called yt. So you have got a time series called xt, you put it inside a filter, produces another time series called yt. So xt is the input while yt is the output. So the same applies if you have got more than one filter. You are going to have a time series. You put it inside the filter. It produces a time series. Put it again inside the filter and produce a time series. So this one, xt, put it inside the filter called filter 1, produces a time series which is called yt. Yt, put inside the filter, which is filter 2, produces another time series which is called, let's say, zt. So this is how the filters works. Any question? Okay, in the absence of any questions, let me proceed. Okay.
So can I ask a question?
Yes, yes.
So since xt is an input to the first filter, right?
Yes.
And the result is yt. So is yt gonna be an input to filter 2?
So in this case, xt is an input. Then you put it inside the filter. It produces an output called yt. At the same time, yt is going to be an input into filter 2 and produces another output, which is zt.
Oh, so yt can act as an input as well?
Yes.
Okay, thank you.
Okay, let me just go to another page. So the series zt it's equal to the summation of ck xt minus k or xt plus k, doesn't matter. So let's say you have got this series zt, which is equal to the summation of ck xt minus k. So in this case, in this scenario, ck is represented by ar and bj. What does that mean? CK is equal to the convolution of the two filters. So in other words, here this one, CK, we call it a weight. This is a weight. And these two, we call them filters. Okay. And this operator here, we call it a convolution operator. For those who are doing mathematics, I think it's not for the first time to come across with this symbol, the star symbol. In mathematics, they call it a binary operator. For those who are doing mathematics, especially in algebra, I think, they have come across with this symbol, star, which they call it a binary operation. So in an operator, so in our case, we call it a convolution operator. What does that mean? It's the convolution of two filters, AR and BJ, which produces what? A weight called CK. So this is the formula that you can use to calculate the weight, the convolution of the two filters. So this formula, you can't use it to calculate the convolution of three filters. It's only for only two filters. You use it only for two filters. More than two, it can't apply. So CK, which is a weight, this CK, which is a weight, is also equal to C0, C1, C2, up to Cn. Okay. So CK can also be equal to this one. What is C0, C1, C2, and Cn? Where C0 is equal to A0, B0. And C1 is equal to A0, B1 plus A1, B0. C2 is A0, B2 plus A1, B1 plus A2, B0. Go like that. C3 equal to A0, B3, A1, B2, A2, B1, A3, B0. So you can just go like that until you generalize. Cn would be equal to A0, Bn plus A1, Bn minus 1 plus A2, Bn minus 2, sorry, minus 1, minus 2 here, plus until An B0. You get it? So see, these are the formulas that you use to calculate C0, C1, C2, C3 up to Cn. So you will understand when we do the example. Any question before I go to the example? None. Okay.
What's the range of the summation there on the T process?
The range on the summation up there. Okay, let me just go back. Oh, this one.
Yes.
For ZT equal to the range is start from 0 up to n, so to speak. As you see here, it's starting from 0 up to n. So obvious k is going to start from 0 up to n, isn't it? You get it?
Yes, sir.
Okay. Now let's go to the example so that you can understand this better. For those who are having the lecture notes, very often we will be referring to the lecture notes. You can open page 22, example 2.4.1. Let's take number A. You have got two filters. Okay, let me just write them down. A equal to a half and a half. This is filter 1 and B filter 2, a half and a half. Okay. And the question says compute or calculate a convolution B. So when they say calculate a convolution B, this simply means that you have to find what? The weight, CK. You have to find CK there in this case. Calculate a convolution B. A is a filter and B is another filter. So you've got two filters here. So they want us to calculate the weight. And remember, I told you that the formula, you can use it to calculate the convolution of only two filters, not more than two. Okay. So now, where do we start? Let's start from this point, C0. You have to calculate C0, C1, C2, up to Cn. C0, if you recall, it's A0, B0. So in this case, what is your A0 and B0? This is A0, and this one is A1. This is B0, and this one is B1. So now it's simple, isn't it? So this is equal to A0 is what? Half. B0 is what? It's half. So the answer is what? It's 1 over 4. It's clear, isn't it? So C1 is A0 B1 plus A1 B0. Okay. A0 B1. So it's 1 over 4 plus 1 over 4. The answer is what? It's a half. Okay. C2 it's A0 B2 A1 B1 A2 B0. Who can tell me the answer there? What is the answer of C2? Who can tell me the answer of C2?
It's 3/4.
It's 1/4 since
3/4.
3/4 or 1/4?
3/4.
No, it's incorrect.
it's 1/4 since we don't have A, and C2. Small a here.
Okay, it's fine. It's fine. The correct answer is 1/4. Why? 1/4. The answer is 1/4. Yeah. The question is why 1/4? Okay, let me explain. If we check this, okay, you have got A0 there. Obviously, you have got A0 there and B2. In those filters, there is no B2 there. There's no B2. So B2 now is 0. So 0 times that one, so it's going to be 0. You get that? The same applies to A2 there. In filter number 1, we don't have A2. So A2 is 0. So 0 times B1 is going to be 0. So this part is 0. But A1 and B1, you have them. It's half and half. So the answer is 1/4.
Sir,
Yes.
can we raise hands when we answer?
You want me to explain again?
No, can we raise hands when we answer? Like in the class, raise hands when we answer.
Oh, raise hands.
Yeah.
Oh no, the problem of raising hands, it won't work because I'm using the window journal. Window journal I can't see what is happening outside. I can be able to see only the window. So that is why I said at the beginning, I think last time, I said that if you have a question, you can unmute your mic and then you raise your question. I will take it from there. So if you can raise your hand, I won't be able to see your hand.
Okay, sir.
Yeah, thank you. Okay, now you have got C0, C1, and C2. Let's continue to C3. C3, remember, is A0, B3, A1, B2, A2, B1, A3, B0. What is the answer? Just tell me the answer. Unmute your mic and tell me the answer.
0.
Yeah, correct. It's 0. All of them. Okay, fine, fine. All of them from C3, C4, C5 until Cn, all of them they're going to be 0. So therefore, your weight Ck, which is equal to C0, C1, C2 is equal to 1/4. We have 1/4. So that's the answer that we have been looking for. But let me just highlight something here. Can you see this process is too long? When you calculate C0, C1, C2, C3, and then you can go to C4, C5, and so on. So the problem is you don't know how many C's you are going to have. C0, C1, how many of them are they going to be there on the weight? So it will be time consuming. So another way to find how many, let me call it weights, are you going to have is this one. If you check your filter A, this one, it's having two weights or two outcomes, or whatever you can call it. You've got two outcomes, half and half. There are two, isn't it? Okay. In filter B, it's half and half. Again, there are two. Okay. Now, if you add the two weights or the two outcomes from A and B, you get what? 4, isn't it? Therefore, because 2 plus 2, then you get 4. Then from there, you subtract 1. Your answer will be what? Will be 3. So that is why you are having C0, C1, and C2. There are 3 of them. You take the two filters, you add the outcomes together, then you subtract 1. They are going to give you the number of weights you are going to get. I think it's clear. Rather than just assuming, just calculate one by one without knowing how many weights are going to have, because it can take time for them. But if you know that how many there are there, so you know it is going to be simple for you to find. Is it clear? Okay. Now, if you don't want to use this method, if this method is too long for you, complicated for you, let me just give you another one that can assist you to calculate the weights. Method number 2. If you don't want to use that one, you can use this one. So you have got the series YT, okay, which is equal to the sum of AJ XT minus J. Okay, that's the first one. The other series is ZT, which is the sum of BJ this time around, YT minus J. Those are the two equations or two time series that you have to consider when you want to calculate the weights. So now let's start with the first one. Here you can say that J is starting from 0 to 1. Why? Because, because here you have got what? A0 and A1. So you can start from 0 to 1. Okay. So you are going to have A0 xt, okay, plus, because of the summation, A1 xt minus 1. Are we together? For formula number 1. So this is equivalent to A0 is what? It's a half, isn't it? So you're going to have a half xt plus A1 is a half, isn't it? It's xt minus 1. Okay, now this is what we are going to get. Yt is equal to half xt plus a half xt minus 1. You put it aside, question number 1. Then you go to question number 2, which is zt equal to summation of bj yt minus j. This is equivalent to what? You do the same thing. So you're going to have b0. Okay. But instead of xt, you are going to have what? Yt. Okay. Plus b1 yt minus 1. Are we together? This is equivalent to b0 is a half. So yt B1 is half yt minus 1. So you have got two equations here now. You have got two equations here. So now you can substitute equation 1, or let's say equation number 2. You can substitute equation number 2 by 1 there. So that means you are going to have from equation number 2. Let me go to the next one. From equation number 2, okay, zt equal to half yt is equal to what? Remember, yt, this one, is equal to this one, equal to this one. So where there is yt, you put the whole of equation number 1 there. Okay, so half, is it xt plus half xt minus 1, if I'm not mistaken. Yeah, this is the one. So remember this part only, we are here. So we have to do the same for this one. Okay. So therefore plus half. That other one is yt minus 1. So in other words, here where there is xt, where is it? Here where there is xt, you put xt minus 1. Where there is xt minus 1, you put xt minus 2, because of this scenario here. Because of this scenario here. Okay. So that means it's half xt minus 1 plus half xt minus 2. Okay. Okay. Now this is equal to, so from this part here, okay, you can take the common factor, isn't it? Take it outside, then it's going to multiply a half. Then you get what? 1/4. Open brackets, xt plus xt minus, isn't it? Then you said plus. The same applies to this case. Take the common factor, take it outside, it's going to be 1/4. So you're going to have 1/4. Then open brackets, xt minus 1, xt minus 2. Are we together? Then later, you find the common factor, which is 1/4. Take it outside. So you're going to get zt equal to 1/4, open brackets, xt plus xt minus 1 plus xt minus 1 plus xt minus 2, isn't it? But here we've got like terms here. these two, you can add them together. You get 1 over 4, open brackets, xt plus 2 xt minus 1 plus xt minus 2, isn't it? Then you multiply through by a quarter, 1 over 4. You get what? 1 over 4 xt plus
Sir,
a quarter multiplied by a 2, you get what?
sir,
Half, isn't it? Yeah?
sir,
Ask.
I'm lost.
From where? Which point? Because we are very far now.
From from the previous page, I was having network problems, so I could not see
Oh,
what we did previously.
okay. Okay. From
Uh,
here, which part? The whole of
yes,
this page you didn't understand. Um.
yes.
Okay, let me just go to the previous one again because said this part you don't understand. Okay, let me start from scratch. I said we are going to have two equations here: time series yt and zt. Talk.
In fact, what are we calculating here?
We are calculating the weight. Isn't that we were calculating the weight before? Then we got 1 over 4, half, and 1 over 4. You still remember that one?
Yes.
Then I said, if that method, the first method, is difficult for you to understand, there is another method that you can use to calculate the weight. This is what we're doing.
So this is thought.
This is the second method. If you don't like that first one, so this is the second method. Maybe you might like it. I don't know. So now, in method
So
number
the,
2,
sir, the summation depends on the number of items inside the
yes,
filters.
yes,
Okay.
that's true. So in this second method, you're supposed to have two equations, time series yt and time series zt. For the first time series there, it's equal to summation of aj xt minus j, which is equivalent to a0 xt plus a1 xt minus 1. But you have got, you know the value of a0, you know the value of a1. So that is why we substitute it here. We just substitute it here for a0 and here for a1. Okay, we get equation number 1. The same applies to time series zt. We are dealing with b's now. The second filter for b. So it's b0 plus yt plus b1 yt minus 1. We substitute b0 by half, then yt plus substitute b1 by half, so yt. So therefore we get to equation number 2. So we have equation number 1 and equation number 2. Then the next page, so we take, that is why I said from equation number 2, we take equation number 2, then we substitute yt and yt minus 1. Okay, we substitute this yt here and yt minus 1. So when we substitute yt here, remember yt is equal to the whole of this. So where there is yt, you put the whole of this. Where there is yt minus 1, you put the whole of this. Rather, where there is xt, you put xt minus 1. Where there is xt minus 1, you put xt minus 2. So that is what we get here. This one and this one. Okay. Then from there, if you check this one, There is a common factor, which is a half. We take it out, then we left with xt plus xt minus 1, which is this one. The same applies to this. There is a common factor, which is a half. We take it out, it multiplies this other half, is 1 over 4. Then open brackets, we have this one. Then from here, you take another common factor, which is a quarter. So that is why we are having something like this. Yeah. It's a quarter outside, then we remain with this thing. And again, if you check, there are like terms, this one and this one. They're the same. So you have to add them together. When you add them together, you get this one. Okay. This is the steps where, the last step where we ended. So now, we have this. So we just multiply through by a quarter. Or 1 over 4. When we multiply through by 1 over 4, so 1 over 4 times xt is 1 over 4 xt plus this plus. Then 2 multiplied by 1 over 4. So 2 multiplied by 1 over 4 is a half. Then take this one. Okay. Then you say plus. A quarter multiplied by xt minus 2 is going to be a quarter xt minus 2. Therefore, zt is equal to that. Okay, so this is the final process. Now, from this final process here, it's where we can get our CK.
Sir, can we, excuse me, sir.
Yes. Yes.
Before we move forward, can you repeat the first method, please?
The first method. Okay, let me just finish this one, then I will go back to the first method so that you can understand it nicely. So for this one, we are done. Remember, we want to find weight CK. So weight CK, now if you check here, this 4 here, 1 over 4, it's our C0. And this one here, it's our C1. And this one here, it's our C2. So therefore, what is left is just to plug in here. So C0, C1, C2, which is equal to what? 1 over 4. A half 1 over 4. Then you're done. If you check this, the answer there is the same as the one we got from the previous method there. You see, it's the same as this one. So before I re-explain method number 1, is there any question? So in other words, you can use method number 1 or method number 2. Yes.
Sir, I heard you saying that you can choose which method you like.
Yes.
Right. So you are not going to force us in a test or an exam that we should use this method.
No, in this case, I won't force you. I will just say, I will give you the 2, maybe 2 or 3 filters. And then from there, I said, calculate the weight. It's up to you which method are you going to apply.
Okay.
Yeah, so I won't, in
Because
this case, I
want
won't force
it.
So there is some cases when I'm going to use, maybe to introduce 2 different methods. And then I will end up saying that this method, you have to know it as well, because I might ask you to use it. Okay. A. But in this case, in this scenario, I won't force you. I will just ask for the weight, then you can choose which method is better for you to use.
Okay.
So there is somebody who said he didn't understand method number 1.
I thought this one was a bit of a process, so that's why I wanted method number 1.
Well, that's why you needed method number 1, but you understood.
Understood.
So
Now.
there is
Understood.
also there is no necessary to explain it again.
Yeah,
But
sure.
anyway, you will understand those methods because there are many exercises on the tutorial and on the exercises. If you can just open, for those who are having the lecture notes, page 22, there is exercise 2.4.1. There are 2 exercises there, A and B. So let's just go and work it out now because we're still having a time. Let me just write it down because there are those who are, maybe they don't have it. So it's exercise 2.4.1, page 22, lecture notes. Okay. Number A. The question says calculate. Let me just write it down. It says calculate the convolution of the following filters. Okay, number A. It says 1/4, 1/4, 1/4, 1/4. That's number convolution 1/4, 1/4, 1/4. Okay. So in other words, in this case, you have to find what? CK. You have to find CK. So I don't know the number of C that are there. I don't know. You will find it out. So let's start with this one. And then later, oh, maybe because this one is too long, let's start with that example 2.4. So this one you can use it as an exercise. Let's do example because this one is too long.
Said
It can take time. Come again.
time
Yeah, I can hear you. I just hear the timing.
is up, sir. Time is
No. Oh, time is up. It's not 10 past 9. Are we not supposed to end at 10 past 9?
It's 10 past 9.
Again, you
Yeah,
took
10
our
past
break.
9.
It's 10
You have a
past.
break.
Yeah, you took our break.
Oh, this is
oh
the
my
break.
watch is forward. So
No, we have to end at 10 past. So we're left with 9 minutes according to my watch. Okay, just go and do example 2.4.1 because this one's too long. The same page 22, and then this one, it's A equal to minus 1 and 1. And 1. B minus 1 and 1. So again, you have to calculate CK, which is a convolution B. Yeah, I think this one, it won't take you even 5 minutes. It's very simple. Calculate and give me the answer. How far are you? For those who are using the first method, C0 is what?
It's 1.
Okay, C0 is 1. C1?
Negative 2.
1, it's
Negative
Minus,
2.
okay. C2?
Is 1.
It's 1. So you're done. So therefore, CK is equal to so your CK is 1 minus 2 minus 2 1. Can I tell you another strategy to see whether you are on the right track? If you have got a weight like this, let me just go to the. If you have got this type of weight, let's say you've got a weight, and you want to calculate C0, C1, C2, C3. You get it? You want to find the values of this one, The strategy that we must, maybe it can work. If here, you know the value of this one, let's say for argument's sake, is 4. Obvious, the last value is going to be the same as that one. It's going to be 4. The only difference is here, in between. This one, they can be different here. You get that? So, but anyway, if you know this one, you know this one. But anyway, you have to calculate it. If you get 4 here, you must expect 4 here. If you get 5 somewhere here and here 4, there is something wrong somewhere. This is another strategy that can make you quick to find the answers. No, let's stop here, and then please just go and do exercise 2.41 A and B. Then on Wednesday we are going to proceed with other stuff, stochastic processes. We're going to do stochastic processes. But anyway, I'm still waiting for the class reps. What is happening?
Yeah, we have only one male class rep, sir.
Find another one.
They're not volunteering, sir.
Oh, but you know the class rep, isn't it?